Okay, so within the Java crash course, we are going to learn the basic Java installation, the IDEs, data types and operators, control flow statements, OOPS concepts. All these will come under the Java basic concepts. And we're going to learn about Git, source code management, what are the DevOps tools, and what are the different front-end frameworks. We're going to work on HTML, CSS, Bootstrap, Angular, and integrate our Java backend with uh, Angular and React frontend. So this is going to be the high level of this crash course. So let's deep dive into our main concept itself, Java. Java is an object-oriented language. This was invented by James Gosling in 1995. The the biggest advantage of Java is platform independence. You just write it once and run it anywhere. Anywhere meaning you can run it in any platform. You have Linux, you have Mac OS, you have Unix, you have Windows. So you have different types of operating systems and different types of platforms. You can run them anywhere. It is architected. Okay, I'm not able to hear. Um, is everyone able to hear me? Okay. Uday Kumar, can you just try reconnecting? Okay. Yeah, and it is architecture neutral, meaning it can run any architecture. It can be ARM based. Like you have different types of architectures within your computer machines. They can be Linux, ARM based. Like within your Windows itself, we have two types of architectures: Windows 64-bit and Windows 32-bit. I think these are the wordings which you have, which you'll be hearing here and often. So Java can run on any architecture, and it is secure. So there's no so it has a bytecode. Like whenever you write a Java, I cannot hear the host voice. Just a minute. Uh, Uday, like everyone is able to hear. Just try reconnecting, or like you can just drop and again rejoin again.
Uh, Hello, Bhavyanath, can you hear me?
I can hear you. Yes.
Yes, yes, now I can hear you, but it's a low voice.
Oh, my voice is low.
Uh, mm, I can
Is it
hear your voice, but it's a quite low.
okay?
One,
Is it the same for everyone? Mhm.
one second, let
Mm,
me.
Yeah, good actually. Your voice is good, no
Yeah,
problem.
yeah. Now I can hear you. Now I can hear you.
Okay.
Yeah.
Thank you. Yeah. So Java is secure, meaning whatever code you write it in .java file. After you compile the .java file, it converts to a .class file. So that .class file has bytecode within it, meaning computer will understand only that bytecode, zeros and ones. It doesn't understand our own English language, and there are no pointers, and we have lots and lots of security mechanisms within our Java framework itself. Hence, it is highly secure, and Java can run within a browser as an applet. Okay, so let's say you have a web application, okay, and you want to play something within the web application. So you need to run Java there. So if you want to run Java within a web application, you use something called as applets. So it can run within your web pages, and it can run on a desktop as an application. Let's say like if you open your Windows, you just click on games. You have lots and lots of games. You have your Minesweeper, you have a Tetris. So all these games these are already embedded within your machine, within a PC. So it can run standalone, like without any input and output. It can run as it is within your application, and it can run on a server. So you can use Java, and like today each and every application, whatever you try to access, if you want to access your Gmail, your Facebook, your Twitter, or whenever we're trying to connect to the same meeting, you use Zoom. So everything is deployed on some server. So I won't say 100%, like at least 20% of that code will be in Java. So Java is involved there. So even your Mac operating systems also use Java, and it can be embedded in a device. So previously you used to have your the old mobile phones, right? Your Nokia mobiles, your Samsung, your BlackBerry mobiles. Whenever you turn on a simple game, you see there Java running. So it can run on that small devices also. So we don't like you don't need some advanced technologies to run Java. You can simply just embed. You can simply um, just install it and run it anywhere. Okay. So so we have currently three Java editions: the Java SE, Java EE, and Java ME. So three editions of Java. Java SE is called the Java Standard Edition. So this has simple basic tools and libraries to build applications and applets. Okay, so it is used to create programs for a desktop computer. So if you want to just create a simple game which doesn't require any internet, simply use the Java SE edition. Most of like a majority of our applications use the Java EE, the enterprise edition. So this is used to create large programs that run on server and manages heavy traffic and complex transactions. Meaning, let's take a simple application called like you take Facebook. Okay, so the homepage itself, the homepage, the backend, and you have lots and lots of customers logging in, like and like let's say suppose if someone just likes a photo, the notification sent to immediately sent to you. So you have these many transactions going within milliseconds. So if you want to handle this scale of operations within your real time, use the Java EE because it has tools and libraries to create a servlet, your JSPs, and all the server-based transactions, everything. It has all the libraries which can be used to create these real-time applications. Okay. The next one is the Java Micro Edition. So if you want like as I said, like within your Nokia, within your BlackBerry or Samsung touchpad phones, you have games there. So if you want to play those games, you require small Java. So for those applications, you can use the Java Micro Edition to develop applications on small devices such as set-top boxes, phone, your appliances. So you can use a Java Micro Edition there. So at the end of the day, you'll be writing the code, but like whenever they ask you like what edition are you using or what like on which environment are you trying to build your application, you can just tell them, okay, I'm going to build a web application. So because you're building a web application, you tell, okay, I'm using the Java EE version. If you're building a simple desktop application, you can tell if anybody is asking, you can tell, okay, I'm building so and so application, I'm using the Java SE. This way. Clear till here? If you have any doubts, you can stop me. You can either speak out or you can just put in the chat window.
Yeah, it's good.
Thank you. Okay. Next comes your JDK. So why do we require a JDK? So let's say now you as a person, if I come to you and speak in some other language which you don't even know, you will not even understand me. So same thing is with the system. So let's say you have a Windows system or a Mac or a Linux or ARM based any system, and if you're writing something and if you're asking it to execute it, the computer needs to know that, okay, so and so input is a Java application. Okay, and I need to compile it and I need to provide some output. So for that system to know that whatever we're doing, whatever input we're sending it is a Java, you need something called a JDK. That's called your Java Development Kit. Okay, so this is your development environment for writing Java applets and applications. So this JDK will sit on like it sits on top of the operating system. Operating system is your Windows, Mac, Linux, ARM based, anything, and it is operating system independent. So you can install JDK on any system. Okay, JDK will have two things. The JRE is called your runtime environment. So what the JRE will have is it has some interpreter and a compiler. Okay, Java C, you'll get to know when we're doing the real coding. So So JRE consists of a compiler and an interpreter. Compiler means you write code in .java file. Like you write something and put a .java extension there. So that is your, like we understand, like whenever you see my code, you'll understand because it's written in Java, English. But the system wants to know, like system will read only zeros and ones. That's called the bytecode. So compiler will compile the code and it will put it in a dot class file. I'll quickly show you an example. Just a minute. Okay, let's say okay, this is a simple application. Okay, I wrote one class and I have a main method and I'm just printing. Okay, welcome to Java. Welcome to Java course. Okay, now if I go to my properties of the file, it is written in Java source file. Means it's a .java file. So like whenever I see my program, I'm able to understand it. Okay, like it's in English, so you can understand it. Now I go to the same directory and if I type Java C, that means I'm asking my Java within my application to compile the code of postprogram.java. So it compiled for me. If I refresh the folder, you see something called as a .class file. So this is the file which the system is going to execute, not this file. See, this is the exact class file. We don't even understand it, but only machine understands it. Now, if I simply run Java post program, I get this output. Welcome to Java course. So for this to work, like now my system needs to know that, okay, whatever first program.java, that is a Java source file. And whenever if I type Java C, it needs to compile this and create a .class file. And whenever I trigger Java space the file name, I need to get this output. So this whole steps will be given by this JDK. Like JDK is just a minute from the current slide. Yeah. So JDK will tell the operating system, okay, put something on the operating system, use a compiler and use a Java interpreter and use them to execute the Java source codes. That's in a simple language. So Java programs are translated into immediate code called bytecode with the help of Java compiler. And this bytecode is platform independent and it can run on any operating system. So if I give that .class file to you, and if you want to run it, simply put it in your desktop, run it. Java, the file name. So to compile and execute, we need JDK, but to run only the bytecode alone, JAR is enough. So JAR means your Java runtime environment. So if you want to run only the bytecode, if you have JRE, you can simply run the class file. But if you want to write your own Java program and run the class file, you need to have a complete JDK. So this is a simple flow. Source file, it's in .java. When you compile it, it converts it to .class file called the bytecode. So this is a simple diagram. Within a JDK, you do the development, you write the code, you test it, you do everything within the JDK, and then it goes to the JRE. So this JRE will consist of a Java virtual machine and all the APIs. So whatever Java C and Java commands, which whatever we are going to use them, those all will come under JVM, Java Virtual Machine. Core classes, libraries, APIs, everything will be coming from your will be embedded within your JRE. So these classes and libraries, like I'll explain you when we're going through the course. So JRE is is simply a subset of JDK, and JVM is a subset of JRE. Okay, understood it? You can put it in the chat window or just speak it out. If you want, I can I will repeat it also. Yep, done. So okay, now we know that like what is Java, which version of Java to use, and we also know like why do we need a JDK and why do we need Java to be installed within a system, and what is the purpose of them. So to use them, we need to install them. For that, we need something called as Java, and we need something called as environment variables. So first of all, like I'm going to share this PPT within the group chat itself, so you can do it. Like with this website, you can download Java. It's a straightforward installation. Just download it based on your machine. If it is Windows, download Windows. If it is Mac, use Mac. Simply click on install, next, 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 and that's it. It installs Java within your application. If you want to check it, just so you'll get a folder called Java here. In this PC, C program files, you'll find something called as Java here. So this will tell you that okay, your Java folder has been created, and alternatively, you can just click on command prompt. Shortcut is Windows R. Windows R. Call the run command. Type in CMD and just type in Java hyphen version. You'll get this. This is a Java version and this is a runtime environment. Okay, just simply follow this link. And later, like now, since you have Java, you can download a JDK also, the Java development kit from this website. Again, the same straightforward steps. Just click on download, install, use the next option. Everything leave it as default and install it. So once you have installed it, this will go into program files into 86. Here you have something called as Java. Here you have the JDK. So this PC C program files into 86 Java JDK. Open this, click on this empty bar here, Control C copy. Just copy the path. And we need to put this in environment variables. So environment variables these are variables which tell the application the actual location of the software. So RPC is a home for many, like you have thousands and thousands of applications which are running within a PC, which we don't even know. Like let's say if you're trying to use a simple Wi-Fi is the icon which we will see, but underneath you'll have Wi-Fi as a service running, wireless as a service running. Like for simple Wi-Fi to run, you have so many programs running, so many drivers which are running within the service. Similarly, if you want let's say if I want to run some Java application, I'm going to run it in my browser or somewhere. I need like my system needs to know where my Java location is. Today I'll put it in one location, tomorrow I'll put it in some other location. So to tell our PC that okay, whenever you're running a Java application, simply come here, take the path from here. So that path is given in environment variables. In Windows, if you want to just open it, just type in environment variables. Edit the system environment variables. Click on environment variables and just give a new option. Variable name is Java underscore home. So all the applications will what you call like they will recognize Java with Java underscore home variable. That's why this is a standard variable name, and the variable value will be your JDK path. Okay, so if you don't put this Java underscore home variable, what will happen is tomorrow if you're going to run your application in some IDE, like today I'm running it in Notepad, tomorrow I'll run it in Eclipse or some other tool. That tool will not know where my Java JDK is. Okay, so that tool will simply come to environment variables. It'll pick up the Java underscore home variable. It'll see the value. It'll simply go to the JDK and execute the program. That is the reason. That is the use of using a environment variable. Getting it? Okay. So now So you simply install Java, install the JDK, and set up the environment variables. And that would be pretty much like you can run any Java program like once you have followed all these steps. Okay. The next comes your Eclipse. So just a minute. So we have something called as IDEs. IDEs are called your integrated development environments. So Eclipse and IntelliJ IDEA are used, like these are the most commonly used for Java applications and Visual Studio Code, and there are many other code editors which will be used for front-end applications. Okay, so why do we need an IDE, or why do we need something to run something? So that can be a question for you. So the main purpose of using an IDE is it provides you an user-friendly interface. It provides you all the like it provides you all the required parameters. It provides you all the required syntaxes. So let me show you a simple program. Okay, let's say I have this IDE. This is called my Eclipse. So now if I want to write the code, whatever I have written in this first program, so I need to type everything: public static void main string args system.out.println. I need to type each and every line here, like if I'm going to use a notepad. But if I'm going to use an IDE, I can make use of these shortcuts: main. So this simple it is. I get the okay. There's an issue with this environment, so it's not running. But this is so simple. So like you need not write everything from scratch. Like you have predefined templates, you have predefined methods there, and you can simply make use of them. Let's say, okay, let's say if you have something and if you want to make some operations, just put a dot, you'll get all these methods. So, so all these are given by your IDEs because they know what package to scan and they know what output what output you require. You can simply make use of these IDs, get the required method, and you will also have something called as documentation here. Like suppose if you want to use name dot length, it'll tell you, okay, this if you use this method, it'll return the length of the string. So this kind of documentation is provided if you use IDs. Hence we use Eclipse and IntelliJ for your Java applications, and for your front-end applications Angular and React, we use Visual Studio Code. That's the most common IDs which we are going to use. We have lots and lots of other IDs also. Like you have Atom, you have PyCharm for Pythons. Like we have different IDs. So within our Java course, we're going to use Eclipse. So this is the download link for Eclipse. Again, straightforward. Just download it. Use the Eclipse IDE for Java and web developers, the second option. So this will use your Java EE version, the Enterprise Edition version. Okay, leave everything as default. Click on, like once you install it, click on Launch to open, and you'll get this type of window once your Eclipse IDE is opened. Let me create a new workspace for you. File. Just a minute. Okay, yeah, it is open here. So this is how you'll get your Eclipse on the startup page. You can create a project, you can import a project, you can create a Maven, you can create Java. This is a simple landing page once you install your Java and Eclipse. Okay. After this, we are going to work something called as Git. So what is Git and why do we need Git is, now let's say now we as a class, I'm going to tell you something like share some Java code. So you people also should like if you want to make use of that code, I need to put it somewhere, and you can take it from that from the cloud. Similarly, now tomorrow if I'm going to update that code, I'm going to update the code and push it, and tomorrow you'll take the updated code. So you need something called as a source code management, SCM. So when you're going to work on large projects, each and every organization, like they'll be working on Git. So whenever you're onboarded to a real-time project, the very first thing is they'll ask you, like if you're working as a developer, the very first thing they're going to ask you is, okay, just clone the source code, do the source code analysis, and give me and tell me what you understand. That's a simple thing which anyone will ask you. So whenever whenever you're onboarded to the project, they'll give you something called as Git repo access. So and they'll give you a Git URL, and they'll just ask you to clone the repo, take the source code, and just analyze the source code. So for that, you need to know what is Git. Git is like take it as a container. Take a container on the web where you store your source code. So from now on, whatever source code which I'm going to write within this course, I'll push it to the Git, and you can pull it from the Git. It's like you're understanding the terminology, right? I'm just pushing my code to upstream, that is to the internet, and from the internet you're going to download it. That's called the pulling. So for that you need to have something called as Git. So this is a download link based on your application, like your PC architecture. Just download them. For Windows, use the 30-bit or the 64-bit, and especially for Mac, just click on install, and you'll be like you'll get this window. So if you type git bash, this is the icon for Git. If you just open it, you need to see this window. This will ensure that okay, you have successfully installed your Git. Okay, any doubts still here till installations and IDEs? Yes, no. Okay. Yeah. So whenever you just see this window, that means your Git is installed. Visual Studio Code, and you require something called as Node.js. So this will be taken care in our third week. So within the third week, we are going to start the front end, right? So there you'll get these installations. So throughout our course, let's make use of this GitHub so that even you'll get the real-time experience when you're working on projects. So I encourage everyone to use their laptops joining this when you're joining this call, so that whatever code which you're going to work on, we're going to do it real time. Let me open. Okay. So github.com. This is the Git URL. This is the GitHub URL. So where we are going to store our source code here. Just click, like if you are an existing customer, click on sign in. Else you just use the sign up button. It's a straightforward Google sign in. You can use the Google sign in itself. Okay. So this is a landing page. This is a landing page. Just click on create a new repository. Provide the repository name. I'm going to put it as Tetra Course 2. Okay. I'm going to put one description here. Repository for okay. I'm going to put it as public. I'm just going to add a README file. And just click on create repository. That's it. So so this is your username and this is your repository name. So let me explain you the whatever titles which you see here. So this is your username and this is your repository name, and it is set to public. Public means anyone with this link, with this URL, will be able to access this repository. If you put as private, right, you'll get an accident error there. Okay, so let's say if you have a banking application, or if you're writing something, if you're writing your proprietary solution and you don't want the solution to be visible to anyone, mark the repository as private, so it will be visible only to whom you grant access to. So if I mark as private and if I add all of your Gmail accounts to that repo access, only you 10 people will be able to access the repository. No one will be able to access. So that's the meaning. So if you click on code, whatever source code is present within our repository, it will be visible here. If you click on issues, like tomorrow, if you're going like tomorrow, if you have, let's say you're trying to run some Java program and you get into an issue, you can simply raise an issue here. Okay, so and so something is not running, and you can submit an issue. I'll get a notification, and we are going to work on the issue, and we are going to mark the issue also. Okay, this issue is caused by so and so. We have resolved it by doing so and so, and the issue is resolved. I mark the issue as resolved. That is the meaning. And you have something called as pull request. So pull request and everything, like when you're working real time, uh, we're going to make use of branching strategies also. So a branch, pull request, and merge request, we're going to discuss it there. Okay, so if you see this symbol, right, this icon, this is called a branch icon. Now currently I'm in main branch. Okay, like when you're working with agile DevOps branches and everything, I'm going to explain you what is a branch and what is the use of it. Okay, so now that we have created this Git repo, let's clone the repo. Cloning means you're going to create a replica of this repository in a local machine. So whatever changes I do in my local machine, I'm going to put it in that repository, and from my local machine, I'm going to push it, and it will be visible here. Now, since you people will have this link, right? And whenever you access this link, whatever code I'm doing it in my local, and since I'm pushing it to my upstream, everyone will be able to access the updated code within this repository. You're getting it? That is the main purpose of we using a source code management tool. Okay, so even if you people just simply copy this and paste it, you'll get this option code. Use the HTTPS clone option. Click on this one, copy. Click on the copy icon. This URL will be copied for you. Open your Git bash. Enter throughout the entire course. Use a specified folder for yourselves. Okay, let me put it as copy. So throughout the entire course, just use a single directory. Paste, enter. CD desktop. mkdir Petracos. Okay. Just cd means change directory. Like whenever you just open your git bash window, just simply change it to your desktop and click on, just type in mkdir. Mkdir means make directory. You're creating a directory called Tetracourse. Make directory and change to the directory. So you're currently in desktop folder now. You change it to Tetracourse. So now your current directory is in desktop and Tetracourse. And here you clone your source code. git clone. Like if you want to run your Java application, you write Java space something, right? Similarly, if you want to run it as a git command, use the git. So simply use the git clone. Clone means you are going to clone the source code, and we take the HTTPS URL, paste it. Just click on right click, paste, enter. So what this will do is this will clone my entire repository, whatever repository which is present in my upstream to my local server. So if I open here, you'll see the readme file. So if you see a green status button, if you see a green button here, that means your local changes and the upstream changes are up to date. So let me do one thing. Add with more plus. Okay. This is a sample commit for readme update. Okay. I just write something and save it, and you'll see exclamation mark here stating that okay, you have made some changes which are specific to your local system, but these are not updated in your upstream. So whenever you see this symbol, right, that means your changes are visible only to you, and no one has the updated code. So what you need to do is you need to push this code. You need to push this file to your upstream. Right click. We can make use of this tortoise git. Okay, so tortoise git is a command, like it's a GUI tool. Like you can just simply I'll tell you like how to install the tortoise git also. Just use a git commit. So if you want to commit some file to the upstream, you need to provide a message like why are you committing it. Okay, first commit. Okay, just click on readme.md, just double click on it and it will tell you the changes also. My previous file has these two lines and within my latest file I have one more line appended here. Okay, now this is my first I have a commit message and I know what file I'm going to push it. I just click on commit and push. So from my local system, it is going to push it to my repository. Okay, now if you see the readme file, it is set to green tick. And if I go to my repository, this is an upstream. Now I made a change in my local system and I committed it. Now if I just refresh the page, you will see something called as first commit. It is updated 26 seconds. Like you can see the real-time timer also running. And if you open this, you can see my updated code. This is where we are going to use the Git source code management. So whatever changes I do it in my local system and I'll push it to upstream. Tomorrow, what you can do is you can simply pull it. Now let's say like we have 10 members here, right? Like one of you people just made a small change. Like you just logged in here, you open the file and you just click on pencil button. This is a sample command for readme update and I updated from the browser. Okay, and I just click on commit changes. Updated me. Just commit from browser. Okay, I click on commit changes. Now what I did, like from a local system, I updated my source code to my repository. Tomorrow, you people wanted to share something to me, so you made some changes by directly in the GitHub. I don't have that source code with me now. So for that, what I do is I go to my now this will be in green tick only because my local system doesn't know that my upstream is updated. Okay, so I simply again use the git pull option now. Make sure within our within your projects also, the most important term, most frequent terms which we'll be using is git commit, git push, git pull. And for the starting time, you use the git clone option. Git clone means you're cloning something from your upstream to your local PC. Git commit and push means you're pushing your file from your local system to upstream. Git pull means you're going to pull from upstream to your local PC. Now, I'll show you the difference also. See, my file is still having the same old 3 lines of code. Okay. Now, let me do a git pull from the main branch. See, you can see here, okay, readme file is changed with 3 insertions and 1 deletion. Now, if I open my Notepad++, this will understand, okay, the file has been changed. Do you want to reload it? Just click on yes, and you'll see this change here. So when you are working in large teams, tomorrow you're going to work in big companies, work with clients, and you have teams team numbers ranging from 5 to 10 or 15. So when you people are working on some piece of code, what you do is you work on your particular piece of code and you commit it to the Git repository. Tomorrow, the third person will take that code and he'll work upon that code and he'll push it. Next, fifth person. So this is a continuous process. You keep writing code and you keep on pushing it so that no one will wait for your changes, or no one will there's no one who will be lost with their changes. At the end of the day, everyone should have their updated code. So whenever you're going to start your day, whenever you're going to start your work on a particular application, the immediate thing is open a source code repository, simply pull the latest changes, because we don't know who changed last night. So it's a good practice to pull all your changes before starting your work, and after starting your work, check for all the unchecked files. If we within a real world, let's say if you want to work on a simple functionality, you need to change 10 to 50 files. Okay, and you check each and every file, but you miss one small file. Okay, that small file will cause a compilation failure, and it'll fail the complete build, the build itself. That's why whenever you're logging off for the day, check for all the files, whatever files which you have edited, check them whether all of them are updated within the repository or not. Because here it's only we are going to how many we have? We have 10 people, right? Here we have 10 participants, and it's going to affect only 10 of us if you miss something. But in a real world application, it's going to affect thousands and thousands of people, because yours is a real-time application running in real world, and it's accessible throughout the internet. Hence, please be very sure that whenever you're working with this Git, make sure you're going to commit only your changes. And when you're writing, there are people who add their comments there. You write some piece of code, and within that you write one comment there. Okay, this piece of code is added by me, will be removed later. So there are developers who write that such piece of code, and they forget removing it when they're going to commit the file. Okay, so whenever you're going to commit these changes, be very sure that you're pushing only source code with relevant comments, and don't push anything. Because the issue with Git is, once you make any change, you have a complete history. If I open my Tortoise Git and if I click on show log, my complete history will be visible within the show log. So no one can do anything. Tomorrow you are going to they'll blame you. If you see the date also, in this time I made this change, in this time I made so and so, in this time I made something from there. So each and every file will have this log. So tomorrow if something is failing and there's a production issue and there's a huge loss, right, they'll simply go check the source code, check the logs, and see the file, and everything will be visible here itself, the author. That's the it can be used in both the ways. So if you want to have a real-time versioning, it's very good. But same, if you make any mistakes, right, those mistakes will be clear-cut pointed out with the show log. It will show you each and every line, whatever change which you have made. This is the previous one. This is the updated one. So it is that important. That's why I'm just stressing on it. Okay. Till here, did everyone understand? Git clone concept, git pull, git push, git commit. Cool. Good. Okay. So whatever I had showed, that those are in the PPT itself. So click on sign up, create a new repository. I'm going to update the source code link. Okay, and share it with you. So git clone, we just did a git clone. We're going to create a Java project. So yeah, so from tomorrow we're going to like again just work on our Java program itself. Like we are going to work on the variables, the data types, all the Java concepts. So there we are going to create this Java project. Okay, let me do it right away. Just a minute, since we have 5 minutes of time. So file, new. Now we are in Eclipse. Since we are working on Java, we are just taking Eclipse IDE as editor, and I'm going to create a new project. Just select the project here. Since we're going to work on Java, it's a Java project. Click on next. Give the project name as Java Basics. Leave everything as default and uncheck this file. We don't require any files here. Just provide a project name and click on finish. Okay. Now, if you expand the Java Basics, you'll get something called as the system library. So this is a Java runtime environment. So whenever you write a simple piece of code, that piece of code should be accessible, like it should be readable. So for that, it requires all these Java jar files. So this JRE is going to take care of it. Okay. So this is like we didn't do anything here. Like whenever you're going to create a Java project, it will automatically set up the path for you. And we're going to work on the SRC folder. So Java hierarchy is you create a project, that is a Java basics, and then you create a package out of it. So just create a small package. The default name convention would be com dot, and you need to start with a lowercase. Okay, like if you start with an uppercase, it'll show you an warning here. Put as com dot java dot basics. Okay, click on finish. So under the SRC means source. You have something called as Java basics. Create a new class now. So hierarchy is again project, package, class. Just click on a class. I put something as basic. Since now this is an IDE, right? IDE will automatically recognize which package we are in. The very first thing within our Java class is the package declaration. So it will tell you our class, which package it is in. This is called a package declaration. Next, public class basic. So your file name will be same as a class name. Later you can, like whenever you want to write some other class, you can add classes within the class also. So when you're doing a real-time coding, you'll get to know. Okay, just put it as a public class and simply write one main method. Now let's say now I have a simple class. If I click on run as, I won't get the run as Java application here. So for us to execute a simple Java application, you need to have something called as a main method. Main, M-A-I-N. Use control space. You'll get the suggestion there. Main method. Hit enter. That's it. Now, since my class has this main method, if I want to run it, I'll get the run a Java application option here. So from now on, if you want to run any Java application within your, if you want to run any Java application, okay, you need to have a main method. And whatever you write within the main method, only those will be executed. Again, same thing, sysout. Welcome to Java. That's it. Right click, run as Java application. That's it. You'll get a output right away here. Sysort means you're asking Java to print something. Whatever is there here, you're asking it to print it. It will show the output here within the console. So this is called a package explorer. So whatever are there in the within this package, it will be visible here. This is your editor itself, and whatever class you want to open, they'll be opened here. This is your problems, the Java doc, declaration, and console. If you want to see any of your outputs, you can check it in the console. If there are any problems here, like let's create one problem, put something and put a semicolon. It will simply throw an error here. Like whatever you have written, that cannot be resolved. So whenever you see any problems here, right, when you close the source code, open them, check the errors, resolve them. Okay. Next is Java doc. You just click on something basic. This is a class. Let's say, if I put as author, right, and like if I just click on Java doc, like whenever now you can see, okay, C for class. Okay, this is a basic is a class file written by so and so. That's called Java doc. Java doc means your Java documentation. Okay. I think this is pretty much it for today. So today we have learned what is Java, what is JDK, what is JRE, different editions of Java, and where to use what edition of Java, and the Java installation, and what are IDEs, why should we use them, and how to install them, what is Git, and what is the use of Git. We also created a repository. We cloned the repository. We made few changes, posted to the repository. We made a pull. We did few Git operations. So this is a quick summary of our today's session. If you people have any doubts in these topics, just let me know. Is everything clear now?